I/O performance. So the most important I/O related settings is DB flash log asterisk commit, which governs the durability in InnoDB. So you can set it to 1 to get the full ACID compliance. On the downside is that you'll be doing a lot of I/O because the flash has to happen after every commit. So you lose your I/O performance. You can set it to 2, and you may lose up to 1 second of transactions when the hardware crashes. You can set it to 0, and you may lose up to 1 second of transaction when MySQL crashes. So obviously 0 or 2 are less write intensive and than the full ACID compliance setting. So it is up to you to pick whatever you like and whatever you need. And this is actually one of those settings which are very important and can make a serious impact, on the performance of your MySQL server. So, for example, if you're running, replication cluster, like master and a couple of slaves, you may want to use those slaves and run them in more relaxed settings, because if you have many of those slaves, you might afford just to wait. If one of them crashes, you may afford it to rebuild it then later. And in the exchange, you benefit from better I/O performance. Same, likewise with Galera. You're running Galera cluster with a couple of nodes. Still, you might maybe relax those settings because if the node goes down, if it crashes, and it will be rebuilt using SSD. So maybe it is acceptable for you to relax those settings and get some gain out of the on the I/O level. Another important settings regarding I/O performance are InnoDB I/O capacity, InnoDB I/O capacity max, and InnoDB LRU scan depth. So those settings basically define the number of operations, of disk operations the InnoDB can execute. So basically, if you set them too low, and you're running on some kind of fast I/O subsystem like fast SSDs or PCI Express SSD cards, you may not fully utilize your software, your hardware. So, but again, more is not always better, because the aggressive flashing, increasing those values will increase the aggressiveness in which MySQL will flash data to the table spaces. And this is not the best option always, because the redo logs are there for some reason. Yes, the main reason for them was to serialize the writes, which is not really that important when you're running on the SSD. But also they are there to minimize the number of writes to table spaces. Because let's say, I don't know, let's say that you have a table and then you insert like 10 million rows and then you delete those 10 million rows, right? So, and to make it worse, let's do it one transaction at a time. So if you would just flash everything to the table spaces, you would just write those rows and then delete them. If you not flash, if everything is stored into redo logs, you just write redo log and you do not make any writes to the table spaces, because eventually those rows were deleted. So so not always more aggressive flashing is better. In LB flash method, it's another setting which is kind of important and can make some difference here. ODirect is usually the best choice most of the time, especially when you're using DBA bucket write card. On the other hand, I've seen all this sync setting which works better with storage area networks, especially actually I've seen it on EBS volumes. So again, benchmark your setup before you go live with production. So the Redl logs, yes, as I said, they're used to store transactions and they're written sequentially. MySQL must not run out of space in them, because then there's a problem and it has to flush the data to free some space. Larger logs help with write merging, as I said. Larger logs help with more stable flushing, because then the adaptive flushing mechanism has more time to kick in and to increase its performance and to actually accommodate those temporary spikes of the write traffic. The downside of large Redl logs is the fact that they may seriously impact the recovery time in case of crash. The rule of thumb is to make them large enough to store at least 1 hour of writes. But of course, again, benchmark, and you will see how, what would be the best for your particular setup. You can easily calculate this rule of, this rule of thumb by going through this process. So set the pager to grep log sequence number, run InnoDB status in some, let's say, in this case, 1 minute interval twice, and then run the select. So subtract the lower value from the higher value, and then convert it to megabytes, and you will see what is more or less how you should size your Redl logs. So in this case, my total Redl log size should be around 8 gigabytes. Again, contentions. So buffer pool instances, table open cache instances, metadata hash, log hash instances, InnoDB adaptive hash index partitions. So these are options which can help you to reduce contentions on those structures. So let's say if you have single buffer pool maybe, and then you're running highly concurrent environment, this can become a point of serialization of the access. So you can increase the number of buffer pool instances to actually benefit from less serialization and, as a result, better performance. So we can either change those settings because you see that something is wrong, or you can do it, preemptively, when you know that you'll be handling, highly concurrent traffic. What's important that don't use buffer pool instances smaller than 1 gigabyte. That's from MySQL documentation. I would say they should be 2 gigabyte plus, because more instances, it also adds some overhead to manage them. So not too much. Max connections, obviously, it keep it large enough so you can accept the secondary connections. You want to avoid having hundreds of open connections because of all those per session buffers which are allocated. So if you have to handle thousands of connections, then you may want to look into the options for connection pooling. That's available for Percona server. I believe it is also available for MariaDB. And MySQL, Oracle made it as part of MySQL Enterprise. So there are connection pooling available for MySQL. You can also configure your proxy to work as a kind of connection pool. Ideally, you could pick a proxy that handles the connection multiplexing, like proxy SQL, which will allow you to go down even more in terms of the number of direct connections to MySQL. Binary logs, you want to have them enabled. That's for sure, because it's for safety, point time recovery, and of course, if you run replication, you have to have binary logs enabled. The one gotcha in MySQL 5.7 is that by default, sync binlog is set to 1, which means that there's a sync after every write to a binary log. It is obviously safer, but it makes MySQL 5.7 slower than 5.6 when it comes to handling write operations. So you may want to revert to the default from 5.6, which was sync binlog set to 0, and OS was handling it for MySQL. So up to you, but you can get a nice performance increase by reverting to the default for MySQL 5.6. Skip name resolve. Use this flag, use the variable, so you won't suffer from issues with the DNS. Query cache, you should just optimize it away by disabling it completely, and just use some other tools like Redis, memcached, Couchbase, whatever. Like most of the key value storage will work fine when integrated in your application.